So our essential question today, how do I find the volume of 3D figures? Three things that we're going to be using today. Base area is a very important one. So again, using area of polygons is a really important factor, concept you need to have down. And having those formulas of those for area of polygons is really important to have access to. Height versus like slant length, right? Big difference there in what you need and what you have. Okay. And then ultimately volume, finding the volume of various solids. So, person had a question on number 18. 18 is not a regular pyramid. The base is not a regular shape. It is a rectangular pyramid. I'm going to draw it slightly differently. It's slightly different. Okay, so there's my rectangular pyramid. All four of these, it said, were right angles. It also said that this slant length here, I'll do this in a different color. This slant length here was 7.3 yards, and this slant length here was 7.8 yards. Okay, so in a case like this, because the base isn't a regular polygon, right? We can't use just one of these slant lengths. And what we have to do is actually say, find the actual lateral area. So we have two triangles here with, and this was 7 yards, and this was 4 yards. So I'm going to draw, basically I'm going to break up this shape, almost do a net. Okay, so here's my rectangle, and this is 7 yards by 4 yards. And then I have a triangle off of each edge there, and a different size triangle off of each edge here. Okay, now I know my triangles don't look like they are congruent opposite wise, but we will say they are. This slant length here again was 7.3 yards, and this one here was 7.8. So if I break it down like this is really, I have two triangles here that have a base of 7 and a height of 7.3. I also have two triangles that have a base of 4 and a height of 7.8. And then I have a rectangle that has dimensions 7 by 4. So what I can actually do is say, all right, well, my lateral area is equal to each of these. I have two of these triangles. So if I said the area of this triangle here is 7 times 7.3, and normally I would divide that by 2, but I have two of them, so when I multiply by 2, those cancel out. So really I just have 7 times 7.3. And then I add that to do the same thing on the other side. I'm going to have 2 times 4 times 7.8, because I have 2 of these smaller triangles. And again, that would be, I divide that by 2, and those 2's would cancel out. So my lateral surface area actually becomes where I'm taking the 7 times 7.3, and which is 51.1, and adding that to 4 times 7.8, which is 31.2. Add those together, gives me a lateral area of 82.3. Okay, so lateral area, and that's going to be square yards. All right. Then to finish up getting surface area, I would then multiply that, or add that, sorry, to the area of the base, because my formula for surface area of a prism, remember, was LA plus area of the base. Lateral area plus area of the base. So we have 82.3 plus 7 times 4 is 28. 82.3 plus 28 is 110.3. And our units, don't forget your units. This is square yards. All right, so things that we're going to be using, all right? Area formula, really, really important, okay? You're still going to be using potentially perimeter if you're talking about like regular polygons, circumference if you're dealing with circles, height, base, radius, right? A big thing on radius is you're not always going to be given the radius on a shape, right? Sometimes you might be given diameter, but you need the radius. So keep in mind and keep vigilant about which one you're given and which one you need. So that way if they give you diameter, you're not plugging the diameter into your formula. You cut that in half and you actually put in the radius. Okay, so volume of polyhedrons. We're going to start with, well, what is volume here real quick? Volume is the space a figure occupies. Okay, space being three-dimensional space. Okay, and volume is always measured in cubic units. Okay, so that means that if we're talking meters, it's cubic meters, or when we write it, it would be meters to the third power. Okay, so if that's what volume is, if we look at a prism, how do we find the volume of a prism? And you need 2 parts for volume pretty much throughout all of these shapes. Volume is equal to the area of the base times the height. For pretty much any shape other than a sphere, volume is base the area of the base times height. Okay? Where here would be our base, just because they put a big B on it. So there's our base. This would also be a base. Those are our bases. Okay? And so one of the things I could do is I could say, well, the area of this base, if I kind of filled that up to 1 unit, okay? So whatever 1 unit was, right, I filled that up, and with whatever, okay, filled that up to 1 unit. So that would be technically my area, or that volume of that base in 1 unit. And then if I multiply that 1 unit by how many units I'd have to do going up, how many of those segments I'd have going up, that would be my total volume. Okay, like filling a pitcher or a box. Okay? So if we take this and said, well, I'm going to be a little bit more specific. I want to do an example here where our base is going to be 22 meters by 20 meters. And our height is equal to 18 meters. Okay? So my first step is to get, I need to know what the shape is, always. Okay, your first step is always to identify your shape. This is a prism, and a rectangular prism, so that first part of the name is going to allow us to identify the formula for the area of the base. And then I start working out the formula. So if my formula for volume is equal to area of the base times height, well, the first thing I need to know is my area of the base. Okay? Area of base. Okay, capital B. Capital B, area of base, which means if this is a rectangle, that is 22 by 20, right? Width times length. So I have 22 times 20, and then I times that by the height, which is going to be 18. Okay? So this 22 times 20, those are each in meters, so the result of that is going to be a meters squared. Meters times meters is meters squared, and 18 is in meters. So when we multiply those things all together, we're going to end up meters cubed. Okay, cubic meters. 22 times 20 times 18 is going to end up being 7,920. Okay, because our height was 18. Okay, so our volume, our total volume of this box, okay, this rectangular prism, is 7,920 cubic meters. All right, next we're going to look at a pyramid. Okay, and the volume of a pyramid also deals with area of the base and height, but because we're dealing with triangles going up to an apex, we actually have this as volume is equal to area of the base times height divided by 3. Okay? So area of a triangle we divided by 2. Volume we divide by 3. Again, with an example, I'm going to use some dimensions of a famous museum in Paris, the Louvre. Yeah. The shape of the museum above ground is a square pyramid. Okay, and it is dimensions of 35.4 meters by 35.4 meters. And it has a height of 21.64 meters. Okay? So if I was to work this out, again, identifying what the shape is a really important part. Okay? So I have my square pyramid. So I want volume. So again, volume is equal to area of the base times height divided by 3 is my volume formula. To find base, well, my area of the base, this is a square. So area of a square is side squared. So I have 35.4, which is my side length, squared. And my height, which is 21.64. So I'm going to have, for volume, I have 35.4 squared times 21.64 and then divided by 3. And it's somewhat easier to do this stuff on top first and then divide it by 3. So 35.4 squared times 21.64 ends up being 27,118.4 divided by 3. And that gives us an approximate volume of the Louvre being 9,039.5. And then our units, because we had meters, meters, and meters, m times m times m is m cubed, or cubic meters. And so the volume of the square pyramid of the Louvre that is above ground is 9,039.5 cubic meters. I wanted to do another example of a pyramid, but this time I wanted to do it in a case where the height wasn't given. Okay? So when we were dealing with surface area, all we were given, normally what we were given was the slant length, right? Well, what if for volume they give you the slant length? Is it still possible to find the volume? And the answer to that is yes. Okay? So on this, I'm going to say this is, on this pyramid, this is a 40 foot by 40 feet. I'm going to do a slant length here and that slant length is going to be 25 feet. Okay? So if I want to know the volume of this, well, my formula says volume is equal to area of the base times height. Height is not slant length. It is from the apex to the center of the base. Okay? This is my height. All right? Height is distance from apex to center of base. So I don't have height in this example, so I need to find it. So how might I do that? Well, one of the things I can do is I can go from this line I drew of height, and I can, where it connects here at the center, I can draw a line over where it connects to my slant length. And that triangle, those two lines, the height and that other small line, will create a 90-degree angle, thus creating a right triangle with where we don't know the height. We do know the slant length of 25 feet. And you might say, well, I only know one side. I don't know any other sides. Well, it might look like that, but really we do, because this point where the height comes down is in the exact center of the base. So it actually splits this 40 feet distance in half. So this distance here is actually 20 feet from the center of the square to the edge is 20 feet. Okay, so now I have two sides, and I solve the third, so I can do Pythagorean theorem. So a squared plus b squared is equal to c squared. And my a squared, I'm going to pick 20. B is h. And c is 25. Okay? So I have now 20 squared plus h squared is equal to 25 squared. 20 squared is 400 plus h squared, and 25 squared is 625. So solving for h squared, I get h squared is equal to 225. I minus the 400 from each side. And then opposite of a square is a square root. So I take the square root of 225, and that would give me that my height is equal to 15 feet. Okay? So now I have the height, so now I can solve for volume. So volume is equal to, again, area of the base times height. My area of my base is a 40-foot square, so that's 40 times 40. And 40 times 40 is 1,600. My height was 15, so now I multiply those things together. So volume is equal to 1,600 times 15, which gives me a volume of, whoops, I needed to divide that by 3. This is all divided by 3. 1,600 times 15 divided by 3. Getting a little out of control with my lines there. which ends up being 24,000 divided by 3. And that ends up being a nice number of exactly 8,000 square feet, or sorry, cubic feet. Volume of non-polyhedrons, so dealing with cylinders, cones, and spheres. First one I'm going to do is a cylinder. Okay, first one I'm going to do is a cylinder. The volume of a cylinder is, again, area of the base times height. That's our general formula for volume of a cylinder. But unlike a prism we couldn't really define any further because our base could be any regular polygon. For a cylinder, we can define it further because our base is always going to be a circle. So the base is always going to be pi r squared. And so, therefore, we can simplify this as volume of a cylinder is always going to be pi r squared times the height. So let's do an example. In this example, I'm going to say that my diameter is equal to 14 units. My height is equal to 12 units. Well, if I look at so I have a cylinder, I have my base stuff, my height. So volume is equal to area of the base times height, which is pi r squared times height. But for this, I need radius. It gives me the diameter. Okay? So I need to, real quick, cut that in half and plug that in. Do not plug in 14 because that's the diameter. So here I'd have pi times 7 squared, 7 is half of 14, times my height of 12. So I get 12 times, or 49 times 12 times pi. (49 times 12) is 588. So I get an exact answer of 588 pi. So that's in terms of pi. And then I'd multiply that using the pi button on the calculator. And that gives me an approximate value of my volume being 1,847.3. And then my units, they didn't tell me specific units. Okay? But I still need to put units down. So this is, you can either put a u cubed or you can put units. Just type out, write out units cubed. Okay? But you need to write down some sort of units, whether they give you units or not. Okay? All right, a cone. Well, the formula for a cone is very similar to that of a pyramid. We saw that in surface area, and it is again true in volume. So again, we have volume is equal to the area of the base times height. And then we divide that by 3. So here, let's say they, again, if they give you the slant length, if they give you L, you're going to need to use Pythagorean theorem to find the height. Slant length and height are not the same thing. Okay, you will get the wrong answer if you use slant length. Use Pythagorean theorem and determine the height if they give you the slant length. Okay, so here if I have my radius is 6 and height is 8, we'll say inches, 6 inches and 8 inches, 6-inch radius, 8-inch height. Again, I'm going to start with my formula. V is equal to area of the base times height divided by 3. And start figuring out the parts. So area of the base. Well, my base is a circle. So really, I could say my base is pi r squared. And so volume might actually be pi r squared height divided by 3. You could use that one as well. Okay? So my base is pi times my radius, which is 6. So 6 squared times my height of 8, which is 36 times 8, or 288 pi is my base. Okay, my height is, pi r, I already did, that was my height, that included my height. So that, we'll back up here, 36 pi would be my base, and then when I take my base times my height, then I get 36 pi times 8, which was 288 pi. Plug in, multiply by 288 by the pi button on your calculator, and we get an approximation of volume of being because we need to still divide by 3, 904.8 over 3. And then divide that by 3, and we get our final of 301.6. And then I look at my units, inches, so that's going to be cubic inches. Inches to the 3rd power. Okay? So a sphere. So a couple things on a sphere. Okay? All right? A sphere for volume, just like its surface area had nothing to do with the rest of the shapes, its volume has no reference to area of a base or height. It is 4/3 pi r cubed. Okay? 4/3 pi r cubed. And so if I said, well, I'm going to look at the volume of a baseball. Okay? What is the volume of a baseball? Well, I could go about this a couple different ways. One, if you've ever done it in science, right? Take whatever you want the volume of, put it in a jar that has a certain amount of water in it, and push the object down into the water, and whatever it displaces, that's its volume, right? But for me, I don't have anything right now to put the baseball in, but I do know that the radius of a baseball is approximately 1.45 inches. Okay, the radius of a baseball is 1.45 inches. So with just that information, I can find the volume of that baseball by saying, all right, well, my radius is 1.45. I plug that into my formula. I get 4. And the easy kind of way to do this is you do 4 times pi times radius cubed, and then divide that all by 3. So 4 times pi times, in this case, 1.45 cubed, and then divide that all by 3. Okay, so if I multiply that all through, I get 4 times pi times 1.45 squared. And that gives me on top 26. That's a bad 2. 26.4 approximately over 3. So divide by 3, and I get that is the approximate volume of a baseball is 8.8 cubic inches. Okay, 8.8 cubic inches would be the volume of a baseball. Now a softball would be a little bit bigger because it has a little bit different radius, but you could definitely figure that out as well. Okay, so there's a couple other things when we're dealing with spheres that I want to define. And the first one is a hemisphere. Okay? Most people, at least when somebody says hemisphere, they think of like the Earth, right? In the top or the bottom half of the Earth. And that's really what you can think of when you think of a hemisphere. It is half of a sphere. Okay? So if I cut a baseball in half, that is a hemisphere. Right? Remember, radius of a sphere. Radius of a sphere is the distance from the center to any edge of a sphere. Okay, it doesn't matter if I draw our radius here flat, or I draw it up, or I draw it over here, or I draw it going backwards to that dashed line, or I draw it coming down, or I draw it connecting to some point in Never Never Land on that other side of that sphere. As long as it connects with some outer portion of that sphere and starts at the center, that's the radius. Okay? Diameter of a sphere is the distance from one side, I guess, of the sphere to the other. Okay, I'm going to say pole, distance from one pole of the sphere to the other. But it has to, that goes through the center. Okay, really important. It has to go through the center of the sphere for it to actually be a diameter. And then, of course, what is the center? It is a point equidistant in space from all edges of the sphere. Okay. I just realized, with some help from some students, that made a error appear. I squared 145, and I needed to cube it on my calculator. So this should have been 38.3 divided by 3, which comes out as approximately 12.8. That sounds a little bit better. 12.8 cubic inches. Here's kind of the hardest challenge problem that you might face on a test. Okay? And that is using either volume to find surface area or surface area to find volume. And really, going from volume to surface area is going to be harder, and I'm going to show you why. Using volume to find surface area. Okay, and we're talking of a sphere right now. Okay, I'm going to do it by a sphere because that's going to be pretty much one of the hardest ones to do. So using volume to find surface area of a sphere. So I'm going to say my volume of my sphere is equal to 5,000 cubic meters. Okay, this is my given. And so if I need to find surface area, well, surface area of a sphere formula is 4 pi r squared. So I need the radius. That's my goal, right? Is I need the radius. So I'm going to look here and say, well, volume is equal to 4/3 pi r cubed. So it also has a radius in it. So I could probably use this to find my radius. And that's exactly what we're actually going to do. Now, I know what my volume already is. It's 5,000. So I'm going to plug that in. 5,000 for the V. Okay? So that gives me 5,000 is equal to 4/3 pi r cubed. Okay? Now, I don't really like fractions, and so the way to get rid of fractions is by multiplying by what's called the reciprocal, or the flip of that fraction. So I'm going to take 4/3, and to cancel out 4/3, I'm going to multiply both sides of this equation by the reciprocal, or 3/4. So 3/4 multiply that side, and multiply this side by 3/4. Well, on the right-hand side, that's really nice because it cancels out that 4 and the 3's. Okay, so I'm just left with pi r cubed. And on the left, I'm left with I'm going to write this as 3 times 5,000 divided by 4 is equal to pi r cubed. Okay? So 3 times 5,000, that's 15,000 divided by 4 equal to pi r cubed. So 15,000 divided by 4 is 3,750. Okay? And now I need to get that radius all by itself, so this is being multiplied by pi. So I'm going to divide by pi. So 3,750 divided by, I'm just going to use the pi button. And that gives me 1,193, I'm going to round it to 0.7, is equal to r cubed. Well, if I want my radius, what this means is, what this is asking for is, what number multiplied by itself is equal, 3 times is equal to 1,193.7. Now, that's not an easily found number, okay? But what you can do is, there's a button on your calculator that looks like this, okay? Has this little X and then the radical symbol. And so what you can do is you can say, well, if I have this number, I can put in a 3. I just hit the number 3 and then this button. So I hit, hold on. So I hit the button 3 and then I hit the button that's x square root, and then I put in 1, 1, 9, 3.7, and then I hit the enter button. Okay? So one of the things this is going to do is this is going to take the cubed root of 1,193.7. Now, what do you do if your calculator doesn't have this, or doesn't have a cubed root of x, or a y x like that? Okay? Well, there's a shortcut, a trick that you can do. Okay? If I take the square root of something, so let's say square root of x. Okay? This is the same as x to the power of 1/2. Okay? If I want to take, and that's a square root. If I want to take the cubed root of something, that is the same as going to the 1/3 power. Taking that same number and putting it to the power of 1/3. A 4th root would then be x to the 1/4. Okay? So this number right here, the 2, the 3, the 4 of whatever root you're taking, is actually called the index. And you'll get more into that into Algebra 2. But pretty much what I'm doing is I'm taking whatever number here, and I'm going to go to the reciprocal of whatever power this is. Okay? So if it's to the 3rd, I'm going to put this to the 1/3. Okay? Or I could do it this way. So if I say 1193.7 to the 1/3 power, because if I do this, r cubed to the 1/3, that cancels those out. 3 times 1/3 is 1. So I'm going to put this to the power of 1/3. Whoops. And that gives me 10.6 is approximately what my radius is. All right? So now that I have my radius, now I can go back up and I can find my surface area. Surface area becomes easy. 4 times pi times 10.6 squared. 4 times pi times 10.6 squared. I get approximately 1,411, or 12 actually, because that rounds. 1,412.0. And then my units were, for surface area, are going to be meters squared. So there's my surface area. So again, this is a type of problem that, of course, is like a level 4 problem, because I make you use other elements or other concepts to get your answer, including maybe more advanced concepts like those radicals. So you might expect something like that on a test.